Hello everybody, today I'm going to be taking you all through the first part of the experiment for the fuel cells for future energy activity. How to complete the electrolysis section can be found in this video just up here or further down on the webpage. On this you can also find the background, a fun origami exercise and an explanation of how this relates to some of the research that's currently happening at the University of Birmingham on batteries. So to do this part of the experiment, this is what you will need. Some potatoes. I'm going to cut these in half to make 6, which is why I also have a knife. You're going to need 6 2-pence coins and 6 galvanized screws or nails, 7 insulated wires with crocodile clips, and a voltmeter. You're going to need an LED and some universal indicator paper. You're also going to need some graph paper or access to a data plotting software such as Excel. This is what I've got just of here. Okay, so onto the activity. I'm going to first go about chopping all of my potatoes in half, so I have 6 components altogether. I'm now going to take my first penny or 2-pence coin and push half of it into one of the potatoes. Like so. I'm then going to do the same thing for the screw so that only about 1 centimeter is showing left. That should be about right. I'm then going to clip both of these to 2 separate crocodile clips. Like so. Then to test whether this works as a battery, I'm going to connect it to an LED. And as you can see, both ways round, it's not really lighting up the LED. Let's check to see whether we can measure any of the voltage via the voltmeter. The black probe always goes into the COM port, and the red probe goes into the V port. Okay, and then I've set this to the V with a straight line and a dashed line because it's a direct current, because this is acting as a small battery. And I've set this on the setting where it just says 20. And you can see here, it reads out -0.7. And so in order to get this to a positive number, I'm going to change it over so that the cable that are bound to my screw binds to the black probe. And as you can see, that turns it positive. So now that's 0.7. So although we didn't see anything with the LED, we know that this has a voltage because it's reading it on the multimeter. And so this voltage wasn't enough to power this LED. What I'm also now going to do, I'm going to record this in my table, so you can either do this as a physical table or one online like I'm doing here. I'm now going to repeat all of these steps, adding 1 potato each time and linking them up with a wire between them. Very importantly, the wire that attaches to the screw of 1 potato needs to attach to the copper coin of the next one. And I'm first going to test if this lights up the LED. Nope. And then I'm going to connect this to the multimeter in order to measure the volts. And as you can see here, I'm getting a reading of 1.71. I'm going to add that to my table, and we're going to repeat this process. Okay, so I've done this for all 6 potatoes now, and I've taken the voltages and wrote the figures down into my table. I now need to double check that this LED works. Oh yeah, there you go. So it does very slightly flickers between on and off when I both add and remove the electrode. However, this is not very bright or powerful, and so either you need to get LEDs that work better with a lower voltage, or you need more batteries. So try and put multiple batteries together, try with more batteries, see how many batteries it takes to power your LEDs. So now that we've recorded all of the different voltages, we can now plot this as a graph to see the trend. Insert recommended chart. If I put this as a simple line chart, label my axes, and then you have your independent variable on the x-axis, and then you have your dependent variable, which is the voltage on your y-axis. As you can see, this is a linear line, and so the more potatoes you add, the more it adds to the voltage. And finally, the last thing that we're going to do is we're going to test the pH of one of these potatoes. Let's go from the start using some pH paper. So I have some universal indicator sticks just up here that go from 0 to 14. And so it's looking sort of like pH 5, pH 6 just up here when it's rubbed near the copper coin. If we rub it near the steel electrode, it sort of looks very similar and the same. So as you see here, the potato has gone very, very, very slightly acidic because neutral is pH 7. So thank you so much for joining me on this activity. I hope you've enjoyed learning about how potatoes can be used to create batteries and how you can use this as a model to measure the voltage and learn how it can affect the pH of the potatoes as well, because the chemical reactions that happen at the anode and the cathode, which we have as a copper coin just up here, and a galvanized steel screw. If you enjoyed this video, ChemBAM have made a bunch of other videos and resources, so please head to the ChemBAM YouTube channel linked down below to see some other really cool up-to-date resources. Please go and have a look at our webpage, also linked down below. Thank you so much. Bye!